All right. So this is the paper that I wanted to go through. Of course, we are not really starting from the last gear. We start with the, every car when you want to start up, you start slow. You don't start from the last gear. I would want us to start from the simple concept, just to warm up our brains before we can start doing tasking concepts. Yeah, so that's what is there. We are starting with the at least the warming up concepts just for today and probably next week. Then from there, I can jump over and start dealing with very complex things. And that should not worry you. Everything is fine and all is well. Okay?
Sure.
Every paper that you write every year, of course, we'll have time to talk, has got this kind of a question on matrices. You're always asked a question on matrices. And I think you can see this question. But before we do this question, I would want us to at least a little bit go backward and look at some key concepts that underpin and guide matrices. And then once we do that, then we can come back and do this exam question to just cement the understanding. How does that sound? Is that right?
It's fine. It's okay.
Okay.
Yes.
Okay, thank you. Let's start very simple. You know, you always have to start easy. Are you able to see my? Okay, just a minute. Okay. Are you able to see the board that I am having?
Yes.
Okay, I am writing down. So we are looking at the matrices per se. So the matrices is an array of numbers that are organized in the rows and the columns. That's the definition. Of course, but it is unnecessary for us to start writing because, I mean, there will be no one who will ask you such, what is a matrix? A matrix is just an array of numbers arranged into the rows and columns. Therefore, a matrix is named by a row and a column. So that's the name of a matrix. Always it is named by a row and a column. For example, let's have this matrix A, and let's have numbers, assuming these are numbers, A and B. Let's just assume A and B are numbers, okay? So what you're going to do is to count the number of rows. Rows are the ones that move to the right, okay? And then we count the column, right? So how many rows do we have here? Yes, sir. How many rows do we have in this matrix? The lines going to the right, horizontal ones.
2.
Okay, thank you. So there are 2 rows times Z. How many columns? Okay, at least we just have only 1 column. So the name of this matrix is called a 2 by 1 matrix. Is that right? Is that clear? We have another matrix, let's call it B, and I just want us to start from the basics so that you can understand properly where we're going. What's the order of this matrix? How many rows are here? Matrix B. How many rows do we have? Okay, at least we just have only 1 row to the right, and there are 2 columns. So this one is said to be a 1 by 2 matrix. Okay, we can have different matrices. Let's have this one. You can have a different matrix A, B, C, and D. This one is said to be a 2 by what? 2 matrix, because there are 2 rows and 2 columns. Is that clear? Hello? Are you still in class? Hello, Mr. Kahale. Are you still in class? So I was saying, to find the determinant, you just multiply, the product of the major diagonal minus the product of the minor diagonal. In this case, you can say A times D minus what? B times C. This will give you the determinant. If you're using numbers, you can say 2 times 5, giving you 10, minus 3 times 4, giving you 12. So that your determinant can be negative 2. Did you get that one? Now, the other question that we can ask ourselves is how to find the inverse. How do you invert a matrix now? How do you find the inverse of a matrix? It's very simple. You just say 1 over the determinant that you have found times, you extend the numbers, the entries in the major diagonal. Where there is D here, D comes here, then they swap with A, okay? So extend the entries, right? Extend the entries. Extend the entries in the major diagonal. And then these numbers in the minor diagonal change signs. If they are all positive, they all become what? Negatives. If they are all negatives, they all become again positive. If one was negative, the other one was positive, the one that was negative should become positive, and vice versa. So that's how it is done. So this is how it is done. First, say 1 over the determinant that you found. Then you say determinant, and you switch the numbers in the major diagonal, and afterwards you change the signs of the entries of the minor diagonal. Any question? Do you have any questions?
Yeah, you said where did you find this sign?
This one. I was saying, if you want now to find the inverse of a matrix, to invert this matrix, you just say 1 over the determinant that you found, then the numbers in the major diagonal here, A and D, they swap positions, okay? A and D swap positions. Then these in the minor diagonal, they change the signs. If it were positive, it becomes negative. If it were negative, it becomes positive. That's how it happens in the minor diagonal. Did you get it?
Yes.
And then from there, you can start multiplying now the determinant times all the entries in the major diagonal. I think we can move direct now to the example that we have been given. We use the exam question. Are you still there?
Yes, I'm here.
Okay. So we have the matrix. The name of the matrix is Q. So let's say matrix Q is 2b minus 1. Let's just write it. It is the matrix Q that is equal to 2b minus 1. What else is there? 4, negative 3b. Okay. There is a 4 here. There is a 4 here, negative 3b, and a negative 5. Let me just confirm if that is the case. Yes. And they are saying that the determinant of this matrix is what? Is 15. So far, are you there?
Yes, I'm here, yes.
Okay, great. At least now your network has done something better. So the question is saying you have to find the value of B if you are given the determinant being 15 of this matrix. We want to find the value of what? B. It's very easy. After finding the value of B, we need to find the inverse of a matrix. So let's go ahead and find the value of B. Since we are already given the determinant, it's very easy. We should just know how to find the determinant, then and equate the matrix to the determinant. You get the point, eh? How do you find the determinant? I said you multiply these numbers in the minor diagonal, right? Major diagonal, isn't it? So you say -5 multiplied by 2b minus 1. Is that clear? Then minus 4 times -3b. Everything should be equal to the determinant, of which the determinant we are already given. It is 15. That's what they have said. So far, do you have any question?
No, yeah.
Hello, is there any question?
It's clear here. I'm following.
Okay, there is no question. Okay, so let's go ahead and for your let's expand. You can say -5 times 2b. This will give us -10b, right? Then -5 times -1, it will give us +5. Why? Because when you multiply same signs, the answer is positive. Negative times negative is positive, right? Positive times positive is positive again. But if you multiply different signs, for example, negative times positive, the answer is negative. Is that clear?
Yes.
Okay. This is one figure minus 4 times 3b. 4 times 3 is actually 12. So have -12b like that equals to 15. We have -10b plus 5 equal to negative times -12. Here will be +12b, huh? Equals to 5. Are you following? Then from here, we can collect like terms together. We're going to have 12b minus 10b equals to 15 minus 5. 15 minus 5 will give us 10 equals to 12b minus 10b is 2b, right? Dividing through by 2, since we just want b, then the value of b will be equal to 5. Do you agree with us?
Yes, I
Hello?
followed. I'm just, yes, I followed it. Very clear. Let me just copy it before you remove
Okay, okay. Not a problem. You can copy. So we are solving this paper. We are solving came in 2022. I think you saw it. This is 2020. We started. Let's start with 2022. In solve 2022, then we solve 2021, 2023, 2020, 2019, 18, up to summer 2016. I think by the time we reach there, you should be fine.
Yes, I hope so, please.
Yeah, I know it shall be fine. It shall be well. You are in the right hands. Yeah. You will tell me when you are done so that we move on to something else. Are we still there in the meeting?
Yes.
Oh, okay. Your network has become stronger now. What has happened?
I've changed the network. I've put the.
You're using Airtel now?
Airtel now.
Oh, you've seen. So you have seen the solution. So next time, just know that it's better you use Airtel. It's a bit stable. Yeah.
No, thank you. Yeah, I'm done copying.
Okay. So now, one thing that you should learn is that this matrix had been, given a B somewhere, because we had not yet found the value of B, right? So it's important that where there is B now, to have the new matrix Q, we replace by putting what? The value of B, okay? So 2 times the value of B is 5, minus 1, negative 3 times B is 5, minus 5, and 4 here. Are you following where I'm finding that? I'm replacing in the same original matrix. We're just relighting, since
Okay.
they were putting B, now we have found the value of B. So the new matrix Q shall be equal to 10, minus 1, 4, negative 15, negative 5. Are we good?
Okay, so where there is
B. You put the value of B.
Where there is
B. Have you seen here there was B? Okay, there was B here, we have put 5. Even here there was B, I've put 5.
Sure.
Okay. So from there we know that Q shall be equal to 10 minus 1 is 9, 4, negative 15 here, and the negative 5. This is our new matrix Q. Do you agree with us?
Oh, 9 is 10 minus 1?
Yes, 10 minus 1 is 9. Then there is 4 there, negative 15 and negative 5. You know where negative 15 is come from?
Yeah, negative 15 is coming from the, yeah.
From 3 times 5.
Oh, 3 times 5.
Negative 3 times 5 here. This negative 3 times 5 is negative 15.
Oh, yeah. Thank you.
Are you okay now?
Yes, thank you so much. Yes,
So this is the first part of the question. It was saying find the value of B. We have already found the value of B. We need to move on now and find the value of what the inverse of the matrix. So we are inverting a new matrix, and our new matrix is matrix Q. So this is our new matrix. Let's invert the matrix. Find the inverse of this matrix. That's what it means to invert the matrix. Our new matrix is this one: 9, negative 15, negative 5, and 4. So this is the one that we are inverting. Okay. Now remember, I've just said that when you're inverting a matrix, or when you're finding the inverse, you say 1 over the determinant. If you remember, 1 over the determinant times, you swap the entries in the major diagonal. So have negative 5 here and 9, right? Then these numbers in the minor diagonal change signs. This was negative 15, will be positive 15. This was positive 4, it will become negative 4 now. Do you agree with me?
Yes.
And we have already found the determinant. What is the value of the determinant? Let's go back to the question. The question clarifies. It says that given that the determinant of the matrix is what? 15. Are you able to see it?
It's 15, yes.
Yes. So the determinant is 15. So where there is determinant, you put 15. Simple. Then you can start multiplying, just the way how you multiply the matrix by a scalar. You start saying 1 over 15 times negative 5, 1 over 15. Like this 1 over 15 will multiply basically with everything inside the parentheses or brackets. 1 over 15 times 15, and 1 over 15 times what? Times 9. Is that clear?
Yes, it is.
The reason why I've done that is so that you can easily follow. You don't easily get confused. So from there, we can say negative 1, 1 times negative 5, obviously this will be negative 5 over 15. On the other hand, this will be negative 4 over 15. We are multiplying. 1 times 15, this will be 15 over 15, right? Then this one will be 9 over 15. Because we're saying 1 times 9, 9, 15 times 1, 15, just like that. You get. So when you reach here, if you want, you can reduce the matrix. You can reduce the. Yes.
Maybe let me copy here before you
erase. Okay.
Please yes, allow me to copy so that.
So this is how the matrix has been inverted, and this is the inverse of a matrix. Just a minute.